Okay, guess what? It's recording again. This is Mr. Bing, Principles of Engineering, Liberty High School. This is activity 2.1.6. We did part 1, 2, 3. Part 1 was the geometry of the angles. Part 2 was the geometry or the length of each of the members of the truss. Part 3 was where we were trying to figure out the balance of the vertical and well, the vertical up and the vertical down forces. And so I think I can show you what I'm talking about here by changing this to here and then waiting for a significant delay for the 2020 technology to make the switch. So let's just find something to chat about, John, while oh, there it is. Never mind. No chat for now, John. This was the part 1, which we figured out all the angles. This was the part 2, where we figured out all the lengths of each member. This was the part 3, where we figured out that all the downward forces have to equal and cancel all the upward forces. And we didn't really get very far with that because we cannot figure out what A sub y and C sub y are separately. All we know is that they add up to 750, and that does not mean that each one is half of 1750. I happen to know because guess what? I've already done it. I happen to know that they are not equal, and don't look at that. Instead, here is what I made my clean little copy of. And we already know that A sub y and C sub y add up to 1750. And I don't know if I have to write that down, but we know that. And in this particular arrangement, we've got a pinned support here, and it actually does have a resistance force in the horizontal, which we don't care about right now, and a roller support. And whenever we're trying to analyze the forces acting on a truss, we need to pick a point of reference or a point of rotation. And it doesn't mean that the truss is actually rotating. It just means that different forces relative to different rotational points. And by the way, I'm gonna make that my rotational point. And I can choose any point I want. Literally anywhere on the truss I can choose as my center of rotation, at least the reference point for the center of rotation. And what we're going to do is measure how all these forces are trying to rotate the truss around that point. We could also try to calculate from this point. We could also try to calculate from this point. You can calculate from any point, but there's happens to be at least 2 points here that are more convenient than any others. And I'm picking this point. That's my favorite little point. You'll see why in just a moment. We have to figure out what kind of twist these forces are trying to apply to this truss. And the reason I picked that one is when you have a force that's being applied right at the center of rotation, it's not creating any twist or potential twist. This force that we don't even really care about really is that's also being applied at the center of rotation. So anytime you apply a force at the center of rotation, it doesn't do any twisting. However, these other 4 forces, they can. If you project this force downward, you could perhaps realize or perhaps see what I'm trying to make you imagine, that there's a twisting that is trying to do clockwise around that point. The same thing here. This one's trying to twist the entire truss clockwise around that point. This one's trying to twist clockwise around that point. Well, you got 3 trying to twist clockwise, and you got this one, very critical, is trying to support it and trying to make the rotation counterclockwise. It turns out that clockwise is negative and counterclockwise is positive. And the way that you figure out how much, it's actually torque or moment, the way you figure out how much torque or function of a twisting as a function of force, this 1000 and this 250 and this 500 have to be each multiplied by their distance from the center of rotation reference point. Well, I forgot what these were. I probably should have made note of that. These it was 3 and 2, and this was 3. And so let me update that. Getting a little sloppy here, Nassim. So this is going to be 3. The distance here is 3, and I know it doesn't look like 3, but we always project that force perpendicular to. It's almost time to wrap it up. This force perpendicular to the rotation. And so that 1000, it turns out, is actually 3 away from the reference point. And this 250, if this is 3 and this is 2, is 5 away from the reference point. And then this 500 is 3 plus 2 plus 2 away from that reference point. So each of those forces, and they're all causing or trying to cause counterclockwise or clockwise, they're all trying to cause clockwise motion. So they're all negative. They're negative something, negative 1000, negative 250, negative 500, but each of them has to be multiplied by their distance from the reference point. This 1000 is 3, so that's 3000, and it's negative. And then this 250 is times 5, and so that's 1250, and that's negative. And then this 500 is 3, 4, 5, 6, 7 away, so that's 3500, and that's negative. Okay, so this negative 3,000, this negative 1,250, and this negative 3,500. What are those numbers? Calculator, iPhone. I have an iPhone SE, Nasim, second generation. It is the iPhone 8 in the body of an iPhone 6. Three, yeah, 3,000 negative minus 1,250 minus 3,500. Okay, so I get the total of these three, the torque or the moment or the twisting, the total is negative 7750, negative 7750. And the units don't really matter right now. I'm just trying to make the math work. And so this C sub y has to twist in reverse, in counterclockwise, equal to that. Well, C sub y times its full distance, which is 3 plus 2 plus 2 plus 3, which is 10. So C sub y, 10 times C sub y, 10 times C sub y has to equal positive 7750. And that would mean that C sub y would be 775. Please check my math, make sure I'm right. And if I already know that A sub y plus C sub y is 1750, and I just found out that C sub y is 775. Well, if you subtract that from what is it? 1750 minus 775, then I get 975. Does that sound right? 975. Okay, that's something. That's something. We're getting there. That's now that we've done 4 parts, we're like 1% done with the problem. Okay, let me switch back to say bye-bye. This is getting sloppier and sloppier as the day goes by. Change to that and then stop recording. Everybody say bye-bye. Lewis, say bye-bye.